Thank you. Now I'm starting.
Okay.
Good afternoon. My name. Okay.
Yes, it's okay. We hear you. And if the
Okay.
audience
Wonderful.
if the audience has questions, so please send them through the panel in the left part of the screen, and I will introduce them to Andrey. Well, come on.
Okay. Thank you. Good afternoon. My name is Andrey Zavadskiy, and I will talk today about unit testing in Microsoft SQL Server databases. For testing, we will use Visual Studio. Just a few words about me. All my work life was connected with databases and applications that uses these databases. The last years was dedicated to SQL Server and Visual Studio. Also, I like to speak at various events organized by Professional Association of SQL Server. Here are my contacts, so if you have a question, feel free to write to me by any way. I hope this session will get you familiar with a database unit testing and give you some examples how to make it in practice. We will use Microsoft SQL Server and Visual Studio. To be more precise, database unit testing is implemented by one of the components of Visual Studio named SQL Server Data Tools, or simply SSDT. And you can get the most from SSDT when you combine SQL Server unit testing with offline database development. Today, we will look at the major steps in database unit testing with SSDT, creating and running unit tests, debugging the T-SQL code, and making some customization. The primary goal of the unit testing is to take the smallest piece of the testable code. In our case, it could be a transact SQL code in stored procedures or functions. Isolate this piece of code from the remaining code and determine whether it behaves exactly as you expect. To achieve this, we need to split the functionality to small blocks, so you can check them with a short and straightforward logic like if then or if then else, and without any complex switch, case, when, and so on. Another important thing is to avoid nested calls to procedures or functions whenever it's possible. This could be implemented by creating fakes or stubs. Unit testing has proven its value in that a large percentage of defects can be identified during its use, even in early phases of the development process. Despite the unit testing has a number of benefits, it's often omitted, especially in database development, because developers say, oh, we don't have enough time to do this, or our code is straightforward, so we will only waste our time in testing. That's not a good answer. Testing should be used wherever possible, but the amount of testing should be in balance between the efforts of developers and the quality of the product. When testing our product, our application database, we are trying to find errors in particular code module. But the bugs can be not only in this code module, but in the test itself too. So the errors can be in two places. Another thing, the other places can also be a source of errors, and that's all those functions and code units that are invoked, that are called by our code module. They are all nested procedure or function calls. This link between code units are called dependency. Generally, we can test everything in our database, but this can consume too much effort from the development team. So you might spend more time in creating tests than in developing the product. So the amount of testing should be reasonable. Every code unit can have input data and or output data. These data can be scalar values or table values. In other words, table values can be named a row set or record set or result set. The meaning is the same. The question, can we test all values and all combinations of values? Maybe, but I would say it's almost unreal. So the good choice of testing scenarios and testing parameters is not a simple case. Nowadays, it's the art of testing. It's a dedicated direction in computer science. And now is the time to create our first simple database unit test and look at the components of SSDT unit test project. Okay, I switch to a virtual machine. Okay, I have a database project with a very simple objects, just one table and two stored procedures. Okay, I open the project structure, my table client. It has a very simple structure, and it has one constraint, or the length of the client name. Stored procedures. The first procedure, create client, creates a new client. It just inserts the record to the table. The second store procedure finds all clients which names contains a text string or a combination of characters in client name field. Also, I have a script that populate the table with initial data. So global unique identifiers, name and email. So to create my database, my tables and my data, I right-click the database project, and in context menu, I select Publish. Okay, my database will be created in the first instance of SQL Server. Okay, I press Publish button. Just wait a little. Okay, my database is created. SSDT has a special menu item for the database object that implement functional logic, such as stored procedures, functions, and triggers. So right-click the Create Client Store Procedure, and you see this item, Create Unit Tests. Now click OK. In this window, I need to select the type of the test project. It can be Visual Basic or C#. I prefer C#. The name of the test project. Okay, I name it Client DB Test Project, and I need to set a test class name. Okay, I prefer a separate class for each database object, so I use this naming convention, SP for store procedure, and the name of my store procedure, SP create client unit test. I delete some characters, so okay, I press OK. Okay, now I need to set a database connection for my database project to database. Okay, I press new connection. Now I enter local to connect to my default instance, and I type clients DB, my database. Now I press OK. Optionally, we can set a secondary data connection. We will talk about later. And optionally, we can set an auto deployment of the database project. This database project, this before the test would be run, but it's not needed in our case. Okay, I press OK, and now I have a database project, client DB test project. And now you see this is, I collapse unneeded items. This is my test class. When I double click the test class, Visual Studio opens a unit test designer. This is a list of my tests in my test class. This is a list of test blocks that are in my test. This is the body of the unit test. The code was created automatically. Declare some variables, then it sets the variables with default values, execute store procedure, and return the value from the store procedures. At the bottom is the list of all available test conditions, from which you can choose the one needed, and the list of here of the test conditions selected for this unit test. By default, the inconclusive, you can see it in the type column. Inconclusive test condition is added to every unit test. This test condition is a stub that will produce a warning during the test running. In many cases, you need to replace it with something meaningful. Okay, I create some simple conditions. Okay, client global unique identifier will be equal to UID function. Client name, okay, it will be tester name. Client email address, it will be tester@company.com. Okay. To start the testing, we need to build the project. Right-click the database project, and then select Build. Okay, my project was built. Now we need to open the Test Explorer. To do this, we need to click Test in menu, then Windows, and then Test Explorer. Okay, I pinned this window. Okay, and now I can run my test. Right-click, and from this menu, I select the first item, Run Selected Tests. Okay, the test is executed. Okay. Okay. Do you see this exclamation? It's a warning because this test is a stub and you need to replace it to something meaningful. Okay, to do this, I select the test and press delete button. No, it's not delete. deleted. Delete again, okay. For example, you will use not empty result set. Select from the list, and now I press the plus button. Okay, this is my test condition, and look here in the properties window. This is my test condition. It is enabled, and it will give the first output. So to check the output, I need to add a simple select statement. For example, select star from dbo.clients. Okay. Now I need to rebuild my project, and now I can run the test again. Okay, wonderful. The test passes. Now we will take a look at the unit test project files. app.config. This file contains a connection strings to databases. Connection string, database source local, and so on. We have set these connection strings while we create a test project. To change it, we should not do it through app.config file. It is implemented by context menu. Right-click the database project and then select the SQL Server test configuration. Now you can set these connection strings at any time that you want. SP create client unit test. This is our test class. This is a test driver or test runner. When you double-click the file, it opens a unit test designer. To view the C# code, you need to right-click this file and select the item view code. So when we scroll down, we will see a function dbo underscore create client test. This is the test runner for our unit test. Okay, now I expand the designer support code region. I scroll down and look here. This is the values, the properties of my test conditions. Wonderful. SSDT save values of the properties in C# file. Okay, another interesting thing is the resource file. You should not change it manually, because SSDT saves data here automatically. Just look here. This is our unit test code. Do you see this new ID function, my tester name, and tester@company.com email address? Okay, the unit test1.cs. It's not necessary anymore. You can delete it without any doubt, and I can't understand why it is created in SSDT. Okay?
Andrey, just a moment. We have
some files.
Andrey?
Okay, yeah.
We have a question due to a misunderstanding. The question was in the beginning of your presentation. So one of the attendees, whose name is, I hope we did correctly, Ravindar Resdi, is asking how to determine how much testing is enough. It was asked in the beginning in the presentation of the tool. Again, how to determine how much testing is enough.
Oh, it's a very complicated and difficult question. It's not for this presentation because there are many Methodics, many theories how to test and how to select values to guarantee the quality of the code. In this presentation, I will show you the technical details, how to test, how the testing can be implemented in Visual Studio. So I think I can make some investigations after the session, and I think I can write a post on my blog about which methods I use in my testing and how to determine how much testing is really needed. Okay?
Well, I hope that this is okay. I will be in contact with to verify if it is fine. Thank you. You can go on.
Okay, now let's go on. Okay. Now I rebuilt my project. So, and this test methods built-in has disappeared. Now I will show you one interesting thing. Open SQL Server Object Explorer. You can open it from View, and here is the SQL Server Object Explorer. Local, Databases, Clients DB, right-click, and now I select the item you query. Select Star from DBO clients. Okay, press Ctrl-Shift-E. Do you see these two last brackets? Tester name, tester name. This is my test data. So when I run the test, the SSDT doesn't automatically delete the testing data. So we need to implement some actions, and we will discuss it later in this session. Okay, as you see in the previous demo, SSDT unit testing consists of test drivers or test runners and unit tests themselves. The test drivers or test runners are C# or Visual Basic classes. These classes execute the T-SQL commands of the unit tests and optional pre-execution or post-execution blocks. Test initialize and test cleanup blocks are defined on the test class level and are executed before and after all unit tests. Unit test can have up to 3 blocks. Pre-test block is needed to prepare the data for this particular test, and post-test block is used to delete the test data. This can be very helpful when you run tests on the database with real data, and you need to preserve its state that was right before the testing. Unit tests in SSDT has some features. By default, every new test has inconclusive test condition. It's a stub that would show a warning when you will execute the test. Also, we can place more test conditions in one test. So, for example, we can check the value in the first column, the value in the second column, the output parameter, or restore procedures, and so on, with different test conditions. Also, you can check the cases when you put the incorrect data, which will cause the violation of constraints. In this situation, SQL Server would raise an error, and you can intercept it in unit test. SSD also has a built-in support to run the test in transaction mode. So there will be no need to write begin transaction and rollback commands explicitly in unit test. If you notice, I had set up only one connection in my unit test project. SSDT has an option to set up another connection, but this one is used in all test blocks before and after the test itself. So it's test initialize, pre and post test, and cleanup. In this demo, we will look at various test scenarios and test conditions and how they can be implemented in SSDT. Okay, for some simplicity of the demonstration, I will use a prepared solution. You can download this solution after this session. I will upload it to my blog and I will send it to virtual chapter leaders so they can upload to your chapter site. Okay, this is my solution. It has a database project. It's the same as it was in previous demo, and a client's DB test project. In the client's DB testing project, I have two test classes for each stored procedure. The first class is SP create client unit test. The stored procedure that we will test creates a new client. I have 3 tests in this test class. Okay, just look at the list. Positive test, negative test, and transaction test. Okay, the first will be our positive test. In this test, I will create a client with a specified global unique identifier, the name Mark Peterson, and here I will check only one test condition that select start from clients where client global unique identifier is equal to the defined value. The properties is not shown. Okay, I press here, and now I will select from the list row count condition 1. Okay, it is enabled. It will get the first result set, and row count is equal to 1. By default, the unit test is not running in a transaction, so when a test finishes, it leaves some garbage data. So we need to clean it up manually. To do this, I defined a delete command in post-test block. So this command will delete my data. Okay, now look at the negative test. In this test, I will insert data with a short client name. This short client name, only 7 characters, would cause a violation of field constraint. It should be more than 9 characters. Okay, and now we test this to test. Build the project. Now switch to Test Explorer. Pin them. Okay. I will run only 2 tests. I select them, right-click, and run selected tests. Okay, positive test okay, negative test has failed. And this is an error message. It is failed because it conflicted with the check constraint. Okay. But I wanted that SSDT should handle this exception and would show that the test passes. So I want to set up the flag that there will be an exception. This can be made by changing the attribute of the test class of the test runner function. Right-click the test class and select View Code. Okay. Look, scroll down. This is our positive test function, and this is our negative test function. To implement the exception handler, I need to write attribute expected SQL exception and set up a message number 547 and severity 16. Okay, I just comment this line and uncomment this line. How to find the error number and severity? You need to copy this code to a query window, run it, and you will see the error message from the SQL Server. Okay, just look down to the transaction function. This is the standard calls that implement the test runner, but this code is wrapped into a transaction scope. Okay, now I can rebuild my project and run 3 tests, this, and this one. Okay, right click, run selected tests. Yeah, wonderful. All my tests passed. When we look at the transaction test, you can see that it has only test block. The post test block is empty. Okay, now let's go to the second test class. The second test class is SP find clients by name unit test. The store procedure that we will test finds all clients which name contains a text string. Okay, double click. I will test the output for names that contains 2 letters, S and T. I have now only one test condition to count the number of rows. I know that there will be 2 rows. And also I want to add a couple of test conditions to check metadata and check values. The first is expected schema. I selected it from the list, then press the plus button. And now I need to configure this test condition. Click here in the configuration line in the properties window, and then click the button with 3 dots. Select the connection to our database. This code was inserted automatically from the database unit test. Now I click retrieve. Okay. Oh, I've missed one step. I should run the client's database project to publish the database, so I will have the initial data. I would do it later. Okay, now I press OK. So I have a metadata, and now I click Save. So I correct my mistake. I publish my database. So I will have a clean data. Okay, and now I will add another test condition, which will be data checksum. Okay, I press plus button. Here is my checksum condition. Click here again in configuration line, then click on the button. I select the connection, clients DB, click retrieve, and now I will have 2 rows exactly as I want. Now click Save All to save the data in my test project. Also, I want to move up the checksum condition to be the first one. Click Save All. Now I rebuild the project, and after that I will run my last test condition, run my last test. Okay, test passes, wonderful. But if we delete one record, our test will fail. It can be implemented very easily. Now I need to switch to SQL Server Object Explorer, local, databases, clients DB, tables. Okay, here is my clients table. Right click, and now I select View Data. Okay, here is my records. Okay, I will delete this record, Mary Stewart. Okay, delete. Yes. And now I will repeat my test, run tests. Okay, the test failed. In the test condition that you see here, checksum, the SSDT does not save the table structure and all table values. Instead, it calculates the checksum value and then compares the checksum of the sample data and the testing data. Yeah, okay. Now we have looked at different tests conditions and how to use them in our testing. SSDT offers the same functionality to debug Transact SQL code like SQL Server Management Studio, but you need to do this via SQL Server Object Explorer. You can set a breakpoint there and then run your code with a debugger. Do not set a breakpoint in your database project. It's not working. It's not the same as in .NET projects. You see a breakpoint in code, then you run it in the debugger, and it stops at the point you have set during correction, modification. Also, SSDT allows to debug the T-SQL code during the unit test, but you can debug only the code being tested. You cannot step through the commands of the unit test itself. Maybe it seems a bit strange because the unit test is written in Transact SQL, but that's the way SSDT works. And now I will show you how to start the debugging. All the steps how to do it is described well in MSDN documentation. And now I will show you it in practice. Return to clients DB test project. Now we need to enable SQL Server debugging. It is defined on the database test project properties. Right-click the database test project, then select properties, then debug tab, and here is the checkbox, enable SQL Server debugging. Okay, wonderful, save. Now we need to increase the connection timeout to a greater value. This is made in app.config file. Double-click app.config, and here we need to set a command timeout value to something greater. For example, 300 seconds. It's 5 minutes. Okay, save. Now we need to rebuild the test project. And now the most important thing, where we set the breakpoint. Open SQL Server Object Explorer, find your store procedure. Here it is, dbo.createClient. Double click. Okay. I already have a breakpoint here. Okay, wonderful. Now we can switch to Test Explorer and run the positive test. Positive test. But in this case, I will select the second item, debug selected tests. I click debug. Okay, do you see this yellow arrow? This is a breakpoint. Now we can step into, step over, step out in our code. Step over, okay. Debug. Now I continue the execution. And here you can see the watch window, autos, pinos, locals, and so on. It's like a SQL Server Management Studio in debugging mode. Now continue. Okay, this is how to set up a debugging environment and run the debugging in our database unit tests. So we can set a breakpoint in our store procedures. But if we switch to our test, positive test, we cannot set a breakpoint here. No option. I click here and no breakpoint. SSDT allows to create custom unit test conditions. How to create them is described in details in MSD documentation. The link is here. Also, you can observe my project on CodePlex, which is available on this address, where I've created a couple of conditions for asserting string and datetime scalar values. And now in this demo, I will show you how to use custom test conditions with your test project. Now, here is my SSDT conditions project. It has a project that will create a DLL. It's the extension for Visual Studio. This code for string value test condition. This code for datetime value condition. This is a test project that will test my test conditions. That is, this works well. All I need is just to build the SSDT conditions project. Now build. Okay, it is built. The very important thing is that for using and developing custom test conditions, you need to open the conditions project in one instance of Visual Studio and a database unit test project in another instance, because the Visual Studio will go mad if you open these two projects in one instance of Visual Studio. Okay. Now I need to copy the DLL from the bin folder. Now right-click the project and then select Open Folder in File Explorer. Now double-click bin folder, double-click debug folder, and here is my SSDT conditions DLL. Now I copy it. Next, I need to paste it to the correct place from where Visual Studio loads extensions. The path is described in MSDN documentation. It's C program files x86, Microsoft Visual Studio 12.0, Common 7, IDE, extensions, Microsoft, SQLDB, test conditions. So now I paste my DLL here. Okay. To use it, I need to close the instance of Visual Studio with my database test project. Okay. Now I need to reopen it. Now Visual Studio loads the extensions. When we look at our client's DB test project and expand references, there is no reference to my DLL. So we can add this DLL manually. References, add the reference, and find the exact place where it is located. But SSD offers a better way to do this. We need to create a new unit test, and the reference will be added automatically. Okay, right-click the database test project, then add, and then new item. Here we select SQL Server. Here is SQL Server unit test. Now click add. This unit test can be deleted after that. And now is my reference to my SSDT conditions DLL. So, okay, when we return to SP create client unit test class, and here is the list of my test conditions. Here is a date time value. It's my own custom condition, and a string value. For example, okay, I can add a string condition. It has, for example, a comparison operator, equals, contains, not contains, starts with, ends with. It's like a string functions in C#. Okay, that's the way how to create a custom condition and use it in your database project. In conclusion, I want to remind you that success of your product, your database, depends on the quality of your code. If you want to get a good product, you need testing. If you need testing, you should pay attention to test plans, test cases, to arrange a good set of testing data, which would cover the functionality and possible input data. Visual Studio, I mean SQL Server Data Tools, gives you a set of tools to create a database project, perform unit testing, make refactoring, and deployment. If you are a database developer, Visual Studio could be a unique framework that gives you enough tools for all your needs. As you saw in the session, unit tests consist of a test class or classes written in C# or Visual Basic. This class implements the test driver or test runner. While the test is executed, it steps through 5 phases: test initialize, prep test, test, post test, and test cleanup. SSDT allows you to step through the code being tested with the help of the debugger. Every test should be quite simple and give an answer just to one question. To check all parts of the output data, you add a test condition to the test block, so you can examine the data from every angle. In addition, you can create your own test conditions and extend the functionality of SSDT. Here are some useful references to documentation about SSDT, to the blog of SSDT developers. Also, if you have a question to Microsoft staff, you can ask them in the MSDN forum. Okay, and now I'm ready to take any questions.
Well, let's wait a minute to see if we have questions. So far, I don't see any, but I will benefit this little break to remind everybody that the presentation will be uploaded to YouTube during this week, and all the materials that Andrey will share with us. We have still more than 10 attendees online, but well, I don't see questions so far. So I have to say thank you very much to Andrey for his effort and for his contribution to our community. And well, I enjoyed very much and it seemed to be very useful. Andrey, thank you, and well, hope to see you again here with our community.
Okay, thank you.
Okay. Thank the audience.
What about the questions?
No, so far we don't have questions. Just a moment. Ravinder raised his hand. Ravinder, try to ask the question. I hope we can hear you.
Yeah.
No, we are not able to hear you. So I suggest you, Ravinder, I suggest you send now the questions in the panel, in the left panel, and I will pass it to Andrey, if it is possible. Just a moment.
Also, another possibility is to write a question in the contact form on my blog. So if you write your question there, I will receive a letter on my email, so I can reply to you.
Well, I see that he says that the following: I have two versions of the same procedures. I don't understand the. I want to test the other procedure. How could it be done through SSDT? I understand that he has two versions of the same procedure, and they want to test the second version, something like this. I hope you understand the question.
Two versions of the same stored procedures, but the stored procedure should have a unique name. How do you have two versions? Well, so it's.
Ravinder, try to clear your question. Well, let's say SP1 and SP2 are two procedures. So I don't understand what is the problem. If we have two different stored procedures, each one can be tested separately. Just a moment. Both have same logic, but different SQL statements. Well, maybe you want to ask how we make a comparison between I think he wants to ask how to test two different stored procedure which with different logic, but that should have the same output. Each one was written in a different way, but the functionality should be the same. So you ask how to compare them, maybe. Yes, exactly. Okay.
Okay. So in this situation, we have two stored procedures. It has the different commands within the stored procedure, but it has the same output. In this situation, we should have two tests, or we need to modify the test manually. So and to replace the name, okay, we have one test. We write it. We execute the first stored procedure. Then we manually change the name of the stored procedures, run the test again, and see the output. Another case, if we write two tests, but it will be quite difficult because we need to copy the test conditions from the first test to the second test, just to test two stored procedures. And if we change the test conditions in one test, we need to repeat all the steps in the second test. So it would better to manually change the name of the stored procedure in one test.
Okay.
Okay, I will look at this situation, and maybe I would find a better solution for this particular case.
Okay. I hope I hope the answer was clear, and otherwise Ravinder can I guess can be in contact with you. You gave the URL of your blog. So I want again to say thanks to Andrey for his effort and for the contribution to our community, and also to all the attendees of this webinar, and hope to see you all again in the future activity of us. Thank you. Spasiba.